properties and characteristics of water. So before we start, pause the video, write down 3 things you know about water. One of the things you might have written down is that water is inorganic. Organic molecules contain carbon. They're closely associated with living things. They're large, complex molecules. Sugar is a great example. Inorganic molecules do not contain carbon. They're not really associated with plant or animal material, and water is a great example. Here is a chemical formula for water, H2O. So take a look at it. How many oxygen atoms do you see? Hopefully you picked 1. How many hydrogen atoms do you see? Hopefully you picked 2. You can see that that hydrogen atom is bonded to the oxygen atoms by sharing electrons. Sharing electrons, you might remember, covalent bonds. So true or false? Water is organic? Hopefully you picked false. How many hydrogen atoms are in water? Hopefully you picked 2. Water is a polar covalent molecule. So it's not just covalent, it's polar. That means it has a positive side. You can see that by the H's, the little plus sign there, and a negative side. You can see that by the O. That's because of the electrons. The electrons spend more time around the large oxygen nucleus, so they bring their electrical charge with them, their negative charge of the electrons. That makes the positive proton of the hydrogen give that side of the molecule a positive charge. Because it's polar, water is a universal solvent. That means that that charge on either side of that molecule helps tear other molecules apart. As a solvent just means it dissolves things. So water dissolves things. Water dissolves things that are hydrophilic. Hydrophilic just means water loving. It can't dissolve nonpolar molecules, things like fats and oils. We might even say fats and oils don't mix. So you take a solute, like salt, you mix it with a solvent, normally water, because water is a universal solvent, and that makes a solution. So we have a salt water solution. Or you could pick anything, Kool-Aid, for example, or Gatorade, for example. If that solution releases hydrogen ions when it's dissolved in water, that makes it an acid. So acids are just solutions that have large amounts of hydrogen ions. Remember that ion just has an electron that's missing in this case. So it's just a proton by the hydrogen. So the higher the hydrogen concentration, the stronger the acid. And it's a strong acid because that hydrogen ion needs to be stable. So it's going to strip electrons from whatever molecule or atom is around for stability. So strong acids strip a lot of electrons, and by doing that they often break a lot of chemical bonds, which is why acids can break things down and they burn. A base is the opposite. Bases have a low hydrogen ion concentration. In fact, they have a higher OH concentration. So the OH has a negative charge. But strong bases do the same thing. They're still looking for stability. They're still dissolving materials because they're trying to be stable. Those atoms need to be stable. So a low hydrogen concentration, and it's measured as a pH of greater than 7. So 0 to 6, acids, 8 to 14, bases. So a 14 is a very, very, very strong acid. A 14 is a very, very, very strong base. A 1 is a very, very strong acid. Right in the middle is water. So the H's and the OH's match up. So that gives us a pH of 7. The H from the acid side, the OH from the base side together, H2O. So write down some things that you've learned so far about water and see if you can, or one of your family members or someone nearby you, can pick out which 2 things are true, which thing is false. Now, life depends on these hydrogen bonds in water. Remember we said it was a polar covalent molecule? That means the opposite sides of this molecule attract to each other. The positive side attracts to the negative side, and it creates this weak hydrogen bond. That gives water some really interesting properties. For example, in my picture here, you can see that water has this little meniscus. That's because of those hydrogen bonds. They are making the water molecules stick to each other and also to the side of the test tube. The silver is mercury. Mercury doesn't have that, and so it kind of mounds up a little bit. So cohesion is a property where The drops of water are attracted to each other. And that creates this phenomenon called surface tension. Adhesion is another property of water where water sticks to other things. And capillary action is a unique aspect of that. We'll talk about that in a second. High specific heat just means water takes a very long time to heat up and a long time to cool down. So that moderates temperature. So your body temperature, because you're mostly made of water, doesn't heat up too quickly or cool down too quickly for that matter. And it also makes ice expand. So as water freezes, it expands, and that allows it to float, which is a unique property of water. So cohesion just means water molecules stick together. So we see like mounding of a water on surfaces, or we see a droplet form. That's the property of cohesion. Surface tension just means that things can rest on the surface of the water, like this water strider. Cohesion, hopefully you picked that it sticks to itself. Surface tension, hopefully you picked water striders rest on the surface. Adhesion means that molecules stick to other things, so water sticks to other surfaces. Capillary action means that water can move through these small spaces, even against gravity. So this is how trees get water from the roots up through the leaves, because the water molecules are attracted to each other and to the sides of those little small tubes. This is also how you can get water to stick in a straw. This is how water moves through paper towels, but how they absorb water is because there's little spaces in that paper towel that draw the water through it, through the cohesion and adhesion properties. High specific heat means that water resists temperature changes. So places near large bodies of water, the temperature doesn't fluctuate very much. I think about hot chocolate. It stays hot for a long time. To get the water to heat up, it takes a long time. That's high specific heat. So hopefully you picked that water sticks to other things. Hopefully you picked that it stays warm for a long time. When water freezes, it expands, so that makes it less dense as a solid. This is unique to water. Other things, when they freeze or become solid, the molecules get closer together, but not ice. This is important because when water freezes, it forms a layer of ice on the surface, which means all that aquatic life doesn't freeze. All that aquatic life can stay alive and warm under that layer of ice. So take the letters W-A-T-E-R and make it an acrostic of some of the facts you now know using the letters for water. So pause the video, make that little acrostic. Which is a true statement about water as a solvent? Hopefully you picked B. What happens to things as they freeze? Hopefully you picked A. And to help you remember some things about water, use this little mnemonic, causes CA. So that's just a little mnemonic to help you remember some of these properties of water.